My name is Barış Yaycı, and this is my Physics 102 project. So, the objective of my experiment was to demonstrate that the inductance of a cylindrical solenoid is influenced by the volume and the number of turns per unit length. To carry out this investigation, I created cylindrical solenoids by a wire and a cylinder. I tied the wire to the cylinder, and then I measured the self-inductance using a multimeter. I recorded the value in the table, and after that I calculated the theoretical value for n number of turns using the equations that I found in my research. And after that I measured the self-inductance of the other solenoid. And finally I compared the self-inductance of the first solenoid with the self-inductance of the second solenoid and look at the error percentage. So I did this process for a total of 6 times. So I did this process for 2 different number of turns, 2 different lengths, and 2 different number of cross-sectional areas. So as you can see here, I am winding the wire to the solenoid. So as you can see here, I calculated the inductance using a multimeter. These are some photos from the measurement process. So, as you can see here, these are my results. Our results confirm that the inductance increases with the number of wire turns and the solenoid's cross-sectional area as predicted. This suggests that the inductance is closely related to these two factors. However, our experiment did show some discrepancies, with the error percentages of 7%, 13%, and 16%. These errors could be due to several factors. One possibility is that the wire was not wound consistently around the cylinder, which would affect the magnetic field and the resulting inductance measurements. Also, the turns on the wire wasn't perfect, since there was a lot of windings on the wire. Some of them got on top of each other and they faced the other side. Additionally, the wires weren't perfectly wound around throughout the length. That might have caused problems. To improve the accuracy of the future experiments, we could take several steps, like we could maybe wound the wire to a robot. The results aligned with the theoretical predictions, and the error percentages were 7, 13, and 16%, which are quite low, so overall our experiment was successful.